All right. I think we can get started. Good evening, everyone, and welcome to the 2023 Drake Awards, the SETI Institute's annual celebration of SETI science and the field's pioneers. I'm Elizebeth Varghese, and I'm honored and delighted to be your host tonight for this worldwide virtual event reception, along with my co-host, friend, and fellow New Yorker, Stanley Fertig. Thank you so much for dialing in from all around the world. I'm so delighted to see this connected community and the passion for SETI. It really reminds me of my own childhood growing up in India and how my interest in space and astrobiology was sparked. Growing up in India in the 1970s, I watched Carl Sagan on Cosmos, and it just inspired me and made me want to learn more. So I've continued to be a space enthusiast. I work and write on the space economy, applications of space tech, space governance and ethics, and I've authored the book Stellar Singularity. I work closely with the SETI Institute, and I'm on the Council of Advisors and lead the people in space business also at Deloitte. As you know, the SETI Institute's mission is really to lead humanity's quest to understand the origins and prevalence of life and intelligence in the universe, and then share that knowledge with our global community. The SETI Institute has 3 centers: the Carl Sagan Center for Research, which hosts more than 100 scientists who investigate the nature of the universe and the prevalence of life beyond Earth. And before we, let me just turn this over and introduce my friend Stan introduce himself, and then we can talk a little bit more about the Drake Awards tonight. Go ahead, Stan. I think you were saying something.
Okay, well, thank you, Elizabeth. My name is Stanley Fertig, and I'm from the Amateur Astronomers Association of New York, or just simply what we call ourselves is the AAA. We're one of the oldest and largest astronomy clubs in North America. Please don't confuse us with the car people. They're AAA.com. We're AAA.org, and we actually predate them. We were founded in 1927 as part of the American Museum of Natural History long before they even thought of building a planetarium. And we're now an independent 501c3. My role at the AAA is multiple. I've been a board member, finance director, editor-in-chief of our newsletter, which is called Eyepiece, and I'm the host of our astronomy podcast called AAA Sky, in one word, which you can find wherever you get podcasts or at aasky.nyc. Let's talk about what we have in store for you tonight. We're going to introduce our panel of previous Drake Award winners and this year's Forward Award winner. And then we'll have a Q&A session where you can ask questions via the Zoom Q&A function to our panel. After all that, we'll turn you over to the live Drake Award ceremony in Menlo Park, where we will, among other things, honor this year's Drake Award recipient, John Rummel, and our Carl Sagan Center Directors Award recipient, Uma Gorti. Along with them, we have a star-studded cast assembled for that event, pun intended. But first, coming right up, Elizebeth has a special guest that she wants to introduce to you. Elizebeth, over to you.
Thank you, Stanley. I do want to introduce our very special guest tonight, Jill Tarter. Before I, get started, I also wanted to give us a little bit about the Drake Award itself and Dr. Frank Drake, who the award is named after. So as many of you may know, the Drake Award is named in honor of Dr. Frank Drake, who was the SETI Institute's first president of its board of trustees. And he is, of course, the renowned creator of this Drake equation. Now, Drake is often called the father of SETI. He penned the Drake equation, I think it was in preparation of a meeting at Green Bank to discuss the first radio astronomy SETI activity. And Drake went on to mount the first observational attempt at detecting intelligence signals in 1960, Project Ozma. And he spearheaded the conversion of Arecibo into a radio astronomy facility. And very importantly, he created the Arecibo message, a digital encoding of an astronomical and biological description of the Earth and all its life forms for transmission into the cosmos. So, big, important pioneer in the field of SETI. And his Drake equation, as you know, really serves the roadmap for astrobiology. It's the equation that, purports to yield a number of technically advanced civilizations in the Milky Way galaxy as a function of a number of other factors. Drake worked with a number of eminent and leading pioneers at the SETI Institute, one of who is Jill. And Jill, we're lucky Jill is with us here today, in the room with us, and I'm so honored to have her on the same Zoom panel as me. Welcome, Jill. She needs no introduction in this room. She is the co-founder of the SETI Institute, a true SETI pioneer, and a trailblazer for women in STEM. She's also, as many of you may know, she is the real-life inspiration for the Ellie Arroway character in Carl Sagan's book and the movie Contact. She was played by Jodie Foster, who I think won an Oscar as well. Jill is one of the most eminent folks who work in this space. She has a bachelor's in engineering physics from Cornell, a master's and PhD in astronomy from UC Berkeley. She served as a project scientist for NASA's SETI program. And once that program was terminated in 1993, the funding was terminated, Jill really led the securement of private funding to continue this exploratory science. She has 2 public service medals from NASA, many, many awards, too many to recount here. She was among Time's 100 most influential people. Now, Jill really inspires me. I'm totally fangirl because, in addition to this amazing science leadership, she is a tireless advocate for science education and creates opportunities for girls and women in STEM. She's a mentor in every sense of the word. Jill, we'd love your perspectives on our, quest at SETI and what to look forward to tonight. Over to you, Jill.
Well, thank you. Thank you so much, Elizabeth and Stanley, too. It's really a pleasure to take part in this Drake Award ceremony each year. But I'd like to do a little aside. So we are honoring Frank Drake, and justly so, tonight, for all of his pioneering work and contributions to this field. But there are a couple of other people that we often don't take the time to set aside and remember their contributions to getting this field started. And I'm thinking particularly about John Billingham and Barney Oliver. These 2 gentlemen were just amazingly thoughtful and had incredible foresight back a long, long time ago. So we had been skimping along with little bits of funding from NASA that John Billingham, who was running the Life Sciences Division at the time, was able to siphon off to keep SETI funding, to keep SETI going in ways that clearly it was not going to be sustainable for the long term. And anybody who got into this business understood that it had to be the long term that you were talking about, because the search that we were talking about and thinking about and envisioning was so vast that it was going to take if not a generation, probably multiple generations in order to either conduct a significant search so that you would be willing to draw some kind of negative conclusion, or more promising, more hopeful, to be successful at searching for evidence of someone else's technology out there. So John Billingham had in his pocket, if you wish, in his hip pocket, a really magnificent advisor in the technological environment, and that's Barney Oliver, who at the time was running HP Labs. And Barney was a huge SETI fan, had been from the very first, when Frank did his first search in Green Bank, West Virginia, which is a difficult place to reach. Barney showed up, just showed up on the doorstep of the Green Bank Observatory. using the resources that Hewlett-Packard could provide. So Barney and JB wondered about how, since it was clearly not looking like NASA, and in particular because NASA's budget has to be approved by Congress each year, it wasn't looking like that was necessarily the best route to establish a significant and stable SETI program. So what to do? Well, these guys figured they didn't actually have the answer. So they decided to hire someone who could perhaps find them the answer. And so they, in fact, contracted with Tom Pearson from San Francisco State University, from their administration division, to conduct a study. So what business model, what financial model, what structural institutional model would be a good solution to this quandary? How do we get a stable SETI program funded and supported and actually implemented over the long time scale, given the fact that it's not a standard NASA project, right? It isn't going to go the way NASA normally does things. And so Tom went off and he came back with a report suggesting a couple of different models. And the one that really made sense was that we should, in fact, form a 501c3 nonprofit, right? And incorporate and raise funds independently and conduct SETI through this vehicle. And so that's incredibly, that wasn't on my horizon before Tom pointed this out. And so we decided, yep, that's what we're going to do. I wrote the charter, and I was pretty far forward thinking, I think, and just was unbounded. And so the charter that I wrote said that the SETI Institute, once incorporated, would be interested in being the supporting housing home for any scientific exploration that had to do with any of the many facets of the question of life beyond Earth, life out there in the universe. And so we weren't locked in to just looking for someone else's techno-signatures. We, in fact, by virtue of this charter, had the freedom to consider all different kinds of questions having to do with life beyond Earth. And that, in fact, has served us extremely well. So I think many of you have heard the story about, we got this charter written and Tom printed it out and jumped in his car and drove to Sacramento and got it approved, right? All in one afternoon. And we were in business. And indeed, the first funding that came through the Institute via that charter was not particularly for techno-signatures. It was, in fact, an astrobiology proposal to look for various types of carbon. And it just, I could not have envisioned back then, when we started with 2 employees, that we would grow to the size and scale that we are today. It's really rewarding to see all of you at the reception last night, to understand how much science we are producing, and to be conscious of the number of places around the world that we are operating today. And it's a huge success story. But again, it's JB and Barney Oliver who really deserve credit, along with Frank Drake, for making this place a reality and for having the stamina and the gumption early on to say, hell no, yes, this is what we're doing. Don't tell us we can't do it. So that's a bit of history, a bit of background that you might not have been aware of.
That's wonderful. Thank you so much, Jill. Really appreciate that background. With that, I will turn this over to Stanley, who's going to walk us through our next set of introductions here with our amazing and eminent panelists who are on with us today.
Okay. So at this point, we're going to introduce the other members of our panel. We have 3 past Drake Award recipients here: Bill Borucki, Dan Werthimer, and Paul Horowitz. Each of them has some amazing accomplishments, which is why they won the award. But first, let me introduce Bill Borucki. Bill is a space scientist who's had a long career with NASA, most recently with the NASA Ames Research Center, where he's perhaps best known as the principal investigator of the Kepler mission, which, as we all know, revolutionized our knowledge of planets in the Milky Way. A longtime friend of the SETI Institute, Bill received the Drake Award in 2015. Bill?
Okay, I'm Bill Borucki. I'm a retired space scientist from NASA Ames Research Center. In 1962, I joined the hypersonic free flight branch to do research related to the Apollo missions to the moon. There I conducted laboratory and theoretical studies of the radiation and plasma environment of entry vehicles. In 1972, after the successful moon landings, I transferred to the theoretical studies branch, where I participated in the development of mathematical models of the Earth's stratosphere to predict the effects of pollution on the ozone. Concurrently, I also investigated the effects of lightning activity in the atmospheres of Venus, Jupiter, and Titan. For that effort, I developed an experiment that determined the optical efficiencies of lightning in planetary atmospheres. In conjunction with spacecraft observations, these measurements were used to deduce the lightning energy available to produce pre-biological molecules in each of those atmospheres. In 1983, I began advocating the development of a space mission that could detect Earth-sized planets and could determine the occurrence frequency of such planets in the habitable zone of sun-like stars. In the succeeding years, my team developed the techniques required to find such small planets and showed that the technology and analysis techniques were sufficiently mature to proceed to flight status. After a successful proposal to the 2000 Discovery Mission opportunity, I was appointed the science principal investigator for the Kepler mission. Frank Drake's original Project Ozma in 1961 and the later SETI searches for signals from technological civilizations have been an inspiration to me and to the science community in general. Such a detection would be an earth-shaking discovery. It would prove that we're not alone. However, in the absence of such a detection, it seemed to me that a parallel approach to determine the extent of life in our galaxy was warranted. The first step was to determine if planets are common and their statistics. Next steps included whether many of these planets are Earth-sized and whether many such planets exist in the habitable zone. The Kepler mission has accomplished these steps and discovered that most stars have planets, that there are billions of Earth-sized or super Earth-sized planets in the habitable zone of their stars. The results help define one of the factors in the Drake equation, namely the number of planets per star. Kepler's results indicate about 2 planets per star.
That's great. Wow.
The next step is to determine if the planets have an atmosphere. If the constituents in that atmosphere indicate the presence of life. The James Webb Telescope and future telescopes will give us the answers to those questions. Then if SETI hasn't already found communicating technological civilizations, it will know which planets to monitor continuously, and possibly SETI will transmit messages from a communicating technological civilization to those planets.
Okay, thank you, Bill. I want to just take this moment to ask all of our panelists to please turn on their cameras. So I'll just say in passing a question that Elizebeth and I were talking about earlier is there intelligent life on Earth? But moving right along, I'm now going to introduce our next panelist, Dan Werthimer. Dan specializes in signal processing for radio astronomy and has been doing SETI since 1979. Dan is co-founder and chief scientist of the SETI at Home project, which we've asked our audience a question about. And he directs other UC Berkeley SETI searches in radio, infrared, and visible wavelengths, including the search for extraterrestrial radio emissions from nearby developed intelligent populations. Dan receives the Drake Award in 2021. Dan, do you have a few words for us?
Thanks, Dan, and thanks to everybody who's tuning in. So a lot of people got me hooked in SETI, but tonight I just want to talk about two important people. So the first guy I want to talk about is who's receiving the Drake Award tonight, John Rummel, and we'll learn a lot more about John later. But I want to tell you about his role in the Berkeley SETI program. So John was a program manager at NASA, and he funded our proposal with NASA funding to build this 7 billion channel spectrometer that we used at the Arecibo Observatory to do a 20-year sky survey. And that spectrometer also ended up providing data for the SETI at Home that we used that data, a couple petabytes. We sent it out to the 7 million participants in 200 countries. A lot of you were engaged in that project, and together with John's instrument and you volunteers and your computers, we did the most sensitive sky survey that's ever been done by Earthlings anyway. So we're very grateful to all the SETI at Home participants and to John for helping us build that instrument. And then that instrument that John helped us build for SETI, it turned out it was kind of a very flexible instrument. It was a signal processing thing that you could use for a whole bunch of different things. And we adapted it for other astronomy applications, radio astronomy, and those instruments that we kind of originally were part of the SETI spectrometer that we kind of switched around. They made a huge number of discoveries at a lot of different observatories. They discovered fast radio burst, a planet made out of solid diamond. Most of the known pulsars were discovered on these SETI machines. They made the first images of the black hole. They measured the baryon density of the universe. And there was a big announcement just a few weeks ago that these SETI machines, they discovered the gravitational wave background, the whole fabric of space constantly jiggling around like jello. So thanks, John, for funding those instruments. Okay, so the second person I want to talk about is the guy that John's award is named after, Frank Drake. And if it weren't for Frank, I would be filthy rich. And the reason is because when the very first microcomputer chips came out in the early 70s, I joined this club called the Homebrew Computer Club. And Steve Wozniak and Steve Jobs were in that club. And everybody got filthy rich because they were building these computers, as was I, but they were, some of them were interested in selling them to people at home. And I, because of Frank, was interested in using those computer chips to do SETI and build SETI spectrometers and look for ET. So I didn't get rich because of Frank, but I did get to work on some of the most fundamental questions that we have as humans. And So later I was fortunate to work with Frank on SETI for about 45 years. And he died just last year. And his insights led to a lot of really cool stuff that a bunch of us on this call worked on: optical SETI, SETI at home, and more recently, in about the last 10 years of Frank's life, he worked on this project called Pano SETI with us. And Paul's going to tell you a little bit more about this new observatory that Frank helped us build, the Pano SETI Observatory. It searches for flashes of light at very short time scales, like nanosecond, microsecond, millisecond time scales, that very few people have looked at the universe on these kind of very short time scales. And it makes a movie of the sky like a billion frames a second. And I'm really excited about this project that Frank helped us launch, because it's exploring this new time scale that nobody's really looked at before. And we don't understand why nature does this, but at all size scales and all frequencies, wavelengths, and probably all time scales, the universe seems to be populated with phenomena. And so whenever astronomers build a new instrument to look at some new phase space, in this case, a new time scale, they discover interesting things. So maybe we'll find some new astrophysical phenomena, or maybe if we're lucky, we'll find ET. And so anyway, because of Frank, I'm not rich, but my life is enriched because of, in a different and kind of wonderful way. And if Earthlings ever find ET, I think we'll have Frank to thank. Thank you.
That's wonderful. Thank you so much, Dan. That was really insightful, and what a great story. With that, I do want to introduce our next panelist, Paul Horowitz. Thank you so much for joining us tonight, Paul. Paul is an emeritus professor of physics and electrical engineering at Harvard. Paul is known for his work in electronics design, as well as for his role in the search for extraterrestrial intelligence, SETI. In the 1980s, Paul designed the first million and billion channel SETI receivers, which laid the groundwork for today's technologies. And he also supervised the construction of the first dedicated optical SETI telescope. Paul received the Drake Award in 2021. Paul, thank you so much again. We'd love to hear from you about, what sparked your journey. And you worked pretty closely with Frank Drake as well. So tell us what,
Yeah, thank you, Elizabeth, and thank you for the SETI Institute for this opportunity. It's really fun to join in my favorite topic these days, and for the last 40 years. Where to inspiration? So when I was at Harvard as a graduate student, there was this junior faculty member by the name of Carl Sagan, and he was teaching a course on intelligent life in the universe. And in fact, he was teaching from notes that eventually became the book that probably some of you have seen, this one here. You got to play a game with these things. Intelligent Life in the Universe, wrote with Shklovsky. And Carl was just a wonderful communicator. And in fact, he funded some of our searches at Harvard. That was the first inspiration. Then I had a professor at Harvard by the name of Edward Purcell. He won the Nobel Prize for the invention of nuclear magnetic resonance, which is the basis of MRI, magnetic resonance imaging. And he had given a talk. I don't know if this will show, you have to have a face in the picture, it doesn't know. Anyway, this is the cover sheet that says, anyway, I'll read it to you. Radio astronomy and communication through space. This is 1960. And he and his graduate student had discovered the 21 centimeter radiation from space. And that was used to map out the galaxy. So he talked about radio astronomy. Then he talked a little bit about space travel and how energetically difficult that was. But then he said, we go back to the fact that we've mapped out the galactic arms with just a tiny, tiny bit of radiation. And that just shows how quiet the universe is, and we could communicate. And he talks a little bit about that. So he was a great inspiration. Then there was, well, let me do it in the other order. Frank Drake came to Harvard, and he gave a series of lectures on radio astronomy and SETI. And, Frank is this gentle giant, I guess I'd put it. He's soft-spoken and brilliant and warm and loving. And it just, that did it. So when I had a sabbatical coming up, I wrote to Frank. In those days you wrote. And I said I was interested in looking for life in Puerto Rico. And he got the joke since he was, head of the Arecibo thing. And he sent me down there, and I've been hooked ever since. The other couple of people are Jill and Barney. Barney Oliver's, let me just say, SETI was considered a little off the beaten path of science, but here's this Nobel Prize winner who thought it was really good. So in some sense, we had Nobel Prize endorsed SETI. And then there's Barney Oliver, who led this Project Cyclops thing. You know the book, right? And he was a big shot at HP, and a brilliant electrical engineer. So this was also endorsed by electrical engineering giants and big shots at Hewlett Packard. What could possibly go wrong? So that's what got me going on this thing. And it's been wonderful ever since. Let me just say one comment about John Rummel, which is we were entirely privately funded at Harvard for these searches, except for 1.5 years. We were funded out of NASA, and that's the money that allowed us to build Beta, the billion channel extraterrestrial assays. And it was because of John Rummel, who appreciated and understood SETI. Let me just answer the one other question that was kind of in the deck here, if I have just another couple of minutes, which is, what lies ahead? The future lies ahead. Who knows? Only the extraterrestrials know what they're sending. And by the way, they may not even be biological. I'd give better than even odds that they're probably machine creatures. And if you're interested in that, read a book called On the Future by Martin Rees, and it may persuade you of the same thing. But I think SETI is moving in a good direction. Thanks to Bill Borucki, that we know that they're now, the sky is littered with planets. Now we're energized, and we're now riding the technological wave. We're using really wonderful processors, GPUs, the kind of thing that Dan's been doing at Berkeley with his people. We've been using arrays. There's SETI Institute's own Allen Telescope array. There's the giant Meerkat array in South Africa. Just a wonderful, wonderful thing, which now the Breakthrough Listen project has instrumentation. I'm told tens of billions of channels. Dan can correct me if that's wrong. So we're using state-of-the-art instrumentation. We're starting to use, Breakthrough Listen has been exploring with this AI and machine learning to sift through the huge amounts of stuff that comes out, including lots of semi-intelligent evidence of life on Earth that contaminates these whole things. And the last comment is we're starting to move into very interesting unexplored regions. For instance, the infrared or terahertz. There's 4 decades of frequency between millimeter waves and infrared. And that stuff sails through the galaxy like a hot knife through butter. And we're not looking there yet. Let me just end with the final thing. In fact, the picture behind my head there, it's not really behind my head, shows one of these things that Dan mentioned. This is the PanaSETI project, an array of, we hope to build about 100 of those modules, which have a Fresnel lens on the front and that cool looking electronics there behind. Whoops, I guess it's there. And we put some prototypes up on Lick Observatory, and the team that is working on this has 3 Drake Award winners. So it's got Dan, Shelley Wright, who's the head, and myself. And it has one of my former students, Andrew Howard, who's a professor at Caltech. Anyway, that's my spiel. And sorry, I went over by a couple of minutes.
Thank you. Go ahead, Stan.
Okay, well, thank you, Paul. At this point, I see we're getting some really good questions, which are many of which are really directed at individual members of the panel. But at this point, I'm going to ask all of our panel members to, as succinctly as you can, answer one question, which is, which do you think we will find first? Microbial life via bias signatures, which I guess technically is not really SETI, unless they're intelligent microbes, or intelligent life via technological signatures or signals. Bill, why don't you take this first?
Good question. It's of course a puzzle. We don't know the future, but certainly I would guess that we'll discover less complex life first. It may be very prevalent on many, many planets, and that the technology to find it is coming along very rapidly. James Webb Telescope, the telescope that will follow that, beginning to look at the atmospheres of planets, what's in those atmospheres. So my bet is that we're going to find life first. With technology. I hope I'm wrong. I'd love to see SETI beat us to that, but my bet right now is with current technology, a lot less complex life first.
Thank you. Paul, do you agree with that?
Yeah, if I'm allowed to include fossil, that is fossilized microbial life, I think yes. I think they're going to find it on Mars. I'm not sure how long that's going to take. And also on some of these moons of the outer planets, if we find something there, it's going to be totally weird. If we find something on Mars, it'll probably look totally familiar, but I think we have a pretty good chance of that, and I'd give that. But just like Bill, I'd rather see SETI succeed because that would be oh so much cooler. But I'll vote with Bill on that.
Okay, Dan?
Yeah, I agree that I think, primitive life is probably likely to be everywhere. Universe is probably teeming. It just popped up so quickly on Earth as soon as the Earth cooled down. So it's probably popping up everywhere. And it might even be in our own backyard on Enceladus or Europa. And I'm excited about Enceladus because it's got the liquid ocean, but it's covered with ice. But there's a cracks in the ice, and there's a kind of a geyser, a plume where this jets are squirting up. And at our lab, they're building a gadget that will fly through the plume and sample what's in the plume and tell if there's some biological stuff. And then the really interesting question is going to be, is it identical to life on Earth at exactly the same chemistry, RNA, DNA, the same 20 amino acids? Because then that's not interesting, because that just rocks fly back and forth between planets and moons. We got a bunch of Mars rocks, in our lab, not because we went to Mars and brought them back, just some big rock hit Mars and all this stuff gets splattered around and some of it comes to Earth. And if you go to Antarctica and you find black rocks on the snow, figure out where they came from. Anyway, so if the life is identical, that just means that maybe we are originally from, Jupiter or Saturn's, we're not Earthlings, or maybe vice versa. But if the life has a different chemistry, that means the universe is teeming with life. Separate biogenesis, separate origin. That'll be really exciting.
I couldn't agree more. Okay, Elizabeth, thank you, all of you.
Wait a minute, Stanley. I want to put my 2 cents in there, right?
Oh,
Can't
Jill,
leave me
please
out.
do. Please do.
And I'm going to disagree with all of you guys, because you're talking about things that are going to happen. Some of them are starting now, and that's great. And all of the things you're talking about will be wonderful. But I'll remind you, we're on the telescope with SETI today. And it could happen, before this program is over, that we actually make a detection. So since we're doing it now, I think there's a reason to vote for that coming first.
Okay, I stand corrected.
Great point, Jill. Thank you. So our hope and optimism continues, maybe by the end of the show, as quickly as that. And the other thing I just want to also remind us, along with the Drake Award today, the SETI Institute has 2 other awards that are being presented tonight. One is the Carl Sagan Center Award for SETI scientists, and the second is the SETI Forward Award. This award honors undergraduates who have had meaningful experience and research in SETI or astrobiology through a very competitive application process. And the award aims to provide opportunities to these students in the hope that, it'll improve their careers and their pathways and opportunities to pursuing careers in SETI. So I wanted to introduce one of this year's SETI Forward Award recipients, who's come through a very competitive process, and she's won this award. Ze-Wen Co, congratulations, and thank you for joining us. Welcome to the evening with our panelists here. Ze-Wen is currently at MIT doing her PhD. She just wrapped up her studies at Cornell, like Jill, and did her research internship that basically earned her the SETI Forward Award. The main idea driving, and Ze-Wen can tell us more, but the main idea driving her work is that Europa's seafloor topography can reveal information about the nature of Europa's geological activity, much like I think what Dan is describing. And Ze-Wen hopes to pursue a career as a planetary scientist. So SETI hopes to see much more of you in the future, Ze-Wen. Now I'll turn this over to Ze-Wen, and please share your perspectives.
Yeah, thank you so much. I'm super honored to be here today as one of the recipients of the SETI Forward Award. I think the search for life is a question that has fundamentally shaped our community, spearheaded by the amazing folk at SETI, like the Drake Award recipients here tonight, and inspired by our innate drive to quote Star Trek, to seek out new life and new civilizations. Following this drive, I was super fortunate as an undergrad to be able to work under the mentorship of Professors Francis Nimmo and Jonathan Lunin, studying whether the upcoming Europa Clipper mission will be able to detect the topography of Europa's seafloor and by proxy geologic activity at Europa. Europa is an icy satellite of Jupiter. We've been talking about this. And if geologically active, it could be one of the prime candidates for life in the solar system. And through this research, we found that gravity measurements made by Europa Clipper will be able to find geologic activity if it exists at Europa's seafloor. So that's super exciting. Yeah, I'm very grateful to have received the SETI Forward Award based on this research, and I'm looking forward to be able to attend conferences like AppSciCon, where I'm hoping to meet all of the interdisciplinary scientists, astrobiologists, geophysicists, exoplanet astronomers, and even more that makes this work all possible. What's next for me is starting my PhD in planetary science here at MIT, where I'll be studying the ancient river systems on Mars and the possibility of past life in that corner of the solar system. I'm hoping that this work will help inform our understanding of how climate plays into having conducive conditions for the formation of life.
Well, super exciting, and hope your move to Boston has gone well. And good luck with the new chapter in your life. Thank you, Ze-Wen. With that, we did have one question from the audience. I just wanted to maybe Dan, if you could be kind enough to answer this. This question was from Tyson and Lauren Dabney. Their question was, how realistic is the gravity messaging that was used for communication in the 3-body problem book series? Any thoughts on this topic?
Yeah, so gravity waves could be used to communicate. It's not a kind of something that Earthlings know how to do, but a very advanced civilization could generate gravity waves. And we already have gravity wave detectors. I'm sure a lot of you are familiar with the LIGO system that's detected gravity waves. You can also use pulsars. That was a recent detected of the background of gravity waves. When the gravity waves go between us and the pulsars, they wiggle, and you can measure the arrival time and detect gravity waves. So we know how to detect gravity waves. To generate them would take a very advanced technology, but the Earth is kind of a middle-aged thing. We're only about 4.5 billion years old, and some stars are 10 billion years old. So you can imagine very advanced civilizations that might be able to generate gravity waves. I think if we ever detect ED, it'd be much more likely to be some sort of electromagnetic thing, some artifact of their technology, maybe their communication or their radar signals, or maybe we could but I do think that a good strategy in SETI is to look for a lot of different things. If you'd asked me 200 years ago what to look for, I would have said smoke signals or fire, and now I'm saying electromagnetic waves. But maybe in 200 years, when you ask me, I'll say, tachyons or subspace communication or something. So we try to do a new kind of SETI search every year, and I think all these different ideas are good. And there was a great paper by Freeman Dyson who thought about advanced civilizations. He was a brilliant thinker. And he wrote a paper called Gravity Machines. And it was the idea that advanced civilizations, we don't know how to do this, could harness the power of stars going around each other, a lot of stars and binary stars. And you could throw objects and they would get this gravitational assist as they fling by a star. And you get an incredible amount of energy out of a system like that. And you could imagine civilizations, harnessing the energy of a binary star, using its gravitational energy. And maybe we'll do that in 1 million years. And you could look for that. Maybe not a deliberate transmission, but maybe just harnessing this energy, having a gravity wave machine that Freeman Dyson wrote about. It's a wonderful paper. And it turns out that when they throw these things into the star to get a gravitational assist, it's in a frequency that LIGO can't pick up now, but there's a new gravity wave detector underway called LISA that will be able to detect the frequency of those gravitational waves if there are gravity machines out there.
Yeah, that's great. Thank you so much. That was really insightful, and thank you for that perspective. Another question that we have, and I'm just doing a time check as well. If anyone wants to take this, or Bill, this was from Mark Elwitz. Given that we now have JWST, and by 2040 we'll have the Habitable Worlds Observatory, do you think that intelligent life can be found using alternative methods, including technosignatures on nearby exoplanets, before radio SETI?
Certainly these telescopes, for the first time, can see the atmospheres, detect the atmospheres. And clearly, if you can tell the atmosphere has oxygen and methane in it, for example, things that don't go together unless there's life, that's a hint that maybe there's life. If you were to find chemical things like chlorofluoromethanes, things that are refrigerants, for example, that go into the atmosphere, you'd say there's intelligent life technological civilizations exist. So I think the future telescopes that exist now and will be coming online in the next 20 or 30 years will be able to detect the existence of life, certainly within the next 50 years.
Great. Thank you, Bill. Anyone want to weigh in? Sorry, go ahead, Stan.
Oh, okay. I know we have some poll results, but I can't see them. So I'm going to go ahead and, sorry?
We got voted out. Optical SETI got 0 votes.
Well, I'm glad you could see the results.
I was going to vote for that, but they said panelists couldn't vote.
Yeah,
so.
I know.
No, life is tough. Okay, so I'm going to ask a question of Bill about your lightning studies, which comes from Tyson and Lauren Dabney. In your lightning studies on other planets, are the radio signatures similar frequencies to Earth's lightning?
Yes, they are quite similar. In almost every way. On Venus, the Russians have sent probes to the surface of Venus, and they've carried lightning detectors, and they find radio waves at similar frequencies, including waves that propagate around the planet, just like they do on Earth.
Okay. Well, here we have a result of another poll result. Do you believe we will find life beyond Earth in our lifetime? And 88% of you said yes. 12% are a little less sanguine about it. But that's a pretty, well, let's hope we're all right.
Maybe the 12%, Stan, are just old people for whom the horizon doesn't stretch as far.
Oh, speak for yourself. Just kidding. Okay, so I'm not sure which one of you would want to take this one. From Arnon Louis, if I pronounced your name right. Did Carl Sagan head the Voyager 1 and Voyager 2 projects at SETI? And what is the latest news from the Voyagers? Who wants to take that one? Any volunteers?
I can say a few words. Certainly they didn't head those projects. Those projects are run by large institutions like NASA Ames or NASA Goddard and so on. NASA, however, brings in these great scientists like Carl Sagan with wonderful ideas and brings them to fruition, but they don't head the mission. Somebody has to, build the rocket and pay for the rocket and all these other things that are required to do the science. So the scientists have a prominent role, but there's a huge army of people that build these missions, design these missions, and operate these missions.
Okay, I'll ask another one. This is a question for Ze-Wen. Ze-Wen, will you be using only optical data in your Mars studies, or are there other techniques that you expect will be useful?
Yeah, so I'm not looking at just optical data. So I'll be using topography and other data sets as well to aid in the study. So this is maybe a little outside of SETI's traditional purview, but there are these two leading hypotheses about what Mars could look like in the early Noachian era, which could be warm and wet, or it could be icy and dry. And looking at kind of these ancient fluvial systems, a condition that would be more conducive for life would be the warmer and wetter condition. So what I'm primarily interested is the amount of water that could have potentially existed in Mars's climate cycle. So I'm looking at things like the topography and hill slopes of these ancient fluvial systems to try and figure out exactly how much water was flowing through these ancient fluvial systems, and in that way determining the climate conditions of early Mars, if it had this warm, wet state, or if it was colder and drier, like other hypotheses.
Okay. Whoops. No. Okay. So I have a question for Dan, which is I just.
Stan, do you want to?
Oh yeah. Okay. It's about. I can never pronounce this. Umwamwa. Yeah, Umwamwa. Do you have any thoughts on what Avi Loeb has said about Umwamwa, etc.?
Yeah. So Avi's cried wolf several times. Whenever there's something new in the sky, Avi thinks it might be a spaceship. Uamuma was one of those times that he cried wolf. When fast radio bursts were discovered, Avi said, well, those are probably coming from another civilization. Uamuma was a rock that came into our solar system. Avi said it was a rocket ship. The latest thing that Avi's been excited about is this meteor that came in at very high speed, hit the ocean, and he said it must have been made out of a very strange material because it would have burned up going at that incredibly high velocity. And also because of its high velocity, it must have been one of these interstellar rocks like Oumuamua that came from a distant solar system, not something going around our own sun. So Avi dredged up, he was hoping to get a rocket engine or a steering wheel or something, but he dredged up these little spherules with a magnetic rake from the ocean seabed. And now he's saying they're interesting spherules. Actually, 2,000 tons of these little BBs get deposited, mostly from meteors, volcanic things, bombs make these. Whenever you heat up stuff, you get these little droplets that are like the size of BBs, a millimeter or something. I think they're just ordinary spherules, but obviously thinks they're pieces of a rocket ship. But extraordinary claims need extraordinary evidence. And so far, there's no data that any of this has anything to do with ET. So even though I think the universe is teeming with life, we need much better evidence.
That's great. Thank you, Dan. And on that note, knowing all of that, right, how do we convince more people to become citizen scientists or, maintain their interest and passion for SETI? Paul, you want to start us off?
Well, I think Dan's the guy on that because of the unmute. Yeah. And well, SETI at Home was a Dan and company project. And so Dan, why don't you respond to that?
So you're asking how to engage the community more generally.
That's right.
I think so. We're thinking about a new SETI at Home project. The Arecibo telescope collapsed. We've been working lately. We've been doing a sky survey on the FAST telescope, which is even bigger than Arecibo, and we've been talking to China about maybe making a new source of SETI at Home data. There are ideas. Jill led a project, and now the Breakthrough Listen has a project where you can analyze data using your brain instead of just using your computer or your cell phone to look at data. There's some things that the computers are not very good at, and then humans end up, even our computers that sift through the data, we end up looking at it visually, inspecting it. And so I think there are some really nice kind of citizen science projects like that. There's some nice, if you have a certain kind of telescope, there are some interesting astronomy and even SETI projects that you can participate in. So everything that we do is open source, and we've had people from all over the world that help us develop the code and make it work better and add things and get the bugs out and make it work on different platforms. And there's been a lot of people helping us in a variety of ways. So there's a lot of goodwill out there. People are really excited about this question. Are we alone? A lot of people want to help if you can harness that spirit.
But Dan, I think we need to not just think about you and I and all of your comrades who are doing all this great work. We need to start early. We need to get citizen science into schools. Yeah. We need to make this part of the curriculum so that students are raised, or they learn that they too can be part of this great scientific exploration and understanding the universe.
Yeah, that's really important what Jill said. I think you look at the people on this call, and a lot of us are kind of aging out, and we need replacements. we developed some curriculum with Lawrence Hall of Science for middle school kids, and Jill spent a lot of time, and Edna DeVore worked on curriculum about SETI, and there's a lot of things that kids can do thinking about, and all these different factors of the Drake equation touch on so many different parts of science and philosophy and social science and anthropology. It's a great way to get kids interested in science.
Great.
Okay, I'm sorry. Well, on that note, I'm not sure we have time for another question, but in any case, I want to remind you all that at the top of the hour in 2 minutes, we're going to switch to the Drake Awards ceremony in Menlo Park, where, among other things, we'll honor this year's winner, John Rummel, and the Carl Sagan Center Directors Award winner, Uma Gorti. And we will have a pretty stellar cast for the event, pun intended. So please stay on the Zoom line after we're finished here. You don't need to do anything at all. You'll be taken directly to the ceremony. We have 1 minute for each of the panelists to very quickly answer. Do you have any final thoughts on SETI or what we've heard tonight or what you want to share with the audience? Let's start with Paul.
Well, I saw that optical SETI got voted out, but I think there's an awful lot of promise in that. It's an unexplored piece of the SETI space. And
okay,
you know, the facts are, with the lasers we have, we could generate optical pulses, which would be so much brighter than our star as seen from afar that it would blow them away.
Okay, Bill.
I agree with Paul. I think optical SETI has got a real future, and I'm delighted to see people try all these different techniques, because we don't know what technique is being used. So I think it's great that SETI is trying all these methods. Godspeed.
Okay, Dan.
I agree. Multiple strategy is the best strategy. Try all kinds of different experiments.
Yeah, I just want to say I'm super happy about initiatives like SETI at Home. I think science should be made accessible to everyone, and I'm happy to see that SETI is spearheading, you know, making science accessible to everyone and having, you know, this initiative.
Wonderful, wonderful. Thank you. I know we're at the end of our time, but don't go away. This does conclude our panel discussion, but if you stay on, as Stan said, you know, you'll be transitioned to the auditorium where you can see the award. Thank you so much, everybody. And thank you, my friend Stanley. It's great fun co-hosting with you. Have a good night and don't hang up.
Okay, good evening once again, ladies and gentlemen. Somebody far more accomplished than I at doing welcomes and introductions and being inspiring has a little message for you. So I'm going to step aside and let that run.
Finding life beyond Earth is no longer a dream. It's a discovery that will likely be made during our lifetime, and it will change everything. We've been here for more than 36 years at the forefront of a quest that many consider science fiction.
Mars is the closest planet where we might find the possibilities of alien life.
We are home to over 100 explorer scientists.
It just takes your breath away.
Our purpose is singular.
Kind of best to understand what you have in your own backyard as you're looking up into the cosmos.
To understand the origins and prevalence of life in the universe.
What we are doing is to try to understand, are we alone in the solar system?
Why do we pursue our mission? Because the discovery of life beyond Earth will lay the framework for humanity's next steps to the stars.
We are trying to understand why we even exist.
We are the SETI Institute.
All right. Thank you, Morgan. So Morgan's a tough act to follow. I'm not going to try. I'll see you later. Have a good night. Anyway, welcome everybody. Thank you so much for coming. We have a wonderful opportunity tonight to celebrate science and to honor some of the people who are active in those scientific disciplines and pursuits. So I'd like to welcome all of you who are here with us tonight. We have lots of friends and followers, colleagues, members of the Board of Trustees. If you're a member of the Board of Trustees, maybe just raise your hand, because as we socialize later, people might want to say hello. So we're honored to have many members of the Board of Trustees here with us tonight. We have members of the Science Advisory Board who help direct and steer the science at the Institute. So maybe you can raise your hands. There's a couple of those folks with us tonight. Many friends and colleagues and some special guests as well, not least my son Christopher, who's joining us here tonight, but also some special guests I wanted to welcome from NASA. And while they're good friends, I'm going to refer to my notes. Well, if they're such good friends, why am I going to refer to my notes? Because the only thing more complex than the kind of science we in NASA do is the titles behind the people at NASA who do these things. So I just wanted to say a special hello to Dr. David Korsmeyer, who's with us from NASA Ames. He's the acting Deputy Center Director and the Deputy Center Director for Research and Technology. And also Dr. Estelle Dodson, the Associate Director of Science Directorate at NASA Ames. So thank you to our good friends at NASA Ames for also being here with us tonight. I'd also like to welcome a special welcome to those of you who are perhaps here for the first time at a SETI Institute event. A show of hands for those of you who are in the audience, a lot of you. So a very special welcome to you. This may be your first, it won't be your last. One of the problems of getting in with the SETI Institute is that we're like the Hotel California. Once you check in, you cannot leave. So very, very big welcome to you. And I also want to welcome the audience we have who's watching from home all over the world with our virtual version of tonight's proceedings. And actually hosting those proceedings is none other than Dr. Jill Tarter, who is the co-founder of the Institute and a SETI pioneer extraordinaire and still an active member of the Board of Trustees. So thanks to Jill, a previous Drake Award honoree, Bill Borucki, who was the principal investigator of NASA's Kepler mission, is also helping us with our virtual program this evening. So we're very grateful to have them with us and with all of you. So again, welcome to everybody. Thank you so much for coming. My job is easy because the next thing I'm supposed to do is really get the hell out of the way and introduce you to our amazing host, who is an astrophysicist, a storyteller, an author, and I think a living and breathing embodiment of the Energizer Bunny, and that is Dr. Moiya McTier. So Moiya.
Thank you so much. Am I live? Yes, I can hear myself. Good evening, everyone. It's so nice to see your lovely faces here in Menlo Park, and a hearty time agnostic greeting, of course, to everyone joining us online. It's really nice to see the blank stare of a camera. Yeah. Like Bill said, I am Dr. Moiya McTier. I am so honored to be hosting the SETI Institute's 2023 Drake Awards. Can we get an applause for the Drake Awards? Yeah, of course. This may be my first time formally working with the Institute. Not the last though, right, Bill? There you go. But my work has been heavily inspired by SETI's research for nearly a decade. I wrote my PhD dissertation on the search for the Milky Way's galactic habitable zone, which is the place in the galaxy where we expect to find the conditions that are ripe for life like us. And my favorite way to teach people science is to get them to speculate realistically about what life might be like on other worlds. And I found it to be pretty effective. Besides my astro work, like Bill said, I'm also a folklorist. I'm an author, a podcaster, a YouTuber, and most importantly tonight, a big old nerd. Can my fellow nerds make some noise? Good. Oh, good. All right, I was hoping that I would get that type of response. You know, all of my Hulu commercials have been telling me that today is the return of Thursday Night Football. And I think that if you're watching this right now instead of that, then honey, you are certainly a nerd. And if you're not already, then by the end of tonight, you will be, because you're going to meet some amazing researchers tonight. Over the last 39 years since SETI was founded, they have stuck true to their mission, a mission that was rooted in faith and fueled by science. And that faith was the undying belief that there is something out there to discover, even if we haven't found evidence yet. You know, a lot of sciences are based on observation, right? That's one of the first steps of the scientific method. A biologist sees a sick person and they go searching for a cure. A chemist sees a weird reaction out in nature and they investigate it. But Frank Drake, Jill Tarter, Andrew Fracknoy, other brilliant SETI minds, they saw no aliens. They detected no signals, but they still searched for them with the best tools and techniques that science had available, and they continue that search today. From scanning the stars in the sky for signals encoded in radio waves to building actual robots designed to dive beneath ocean waves on other worlds, the SETI Institute has been on a quest to understand the origins and prevalence of life and intelligence in the universe, and to share that knowledge with the world. As a science communicator, I don't think there's a cause or action more noble than sharing information. And as a folklorist, I can't think of another scientific organization whose mission focuses on a more globally pondered question. Myths and folklore from around the world throughout time are full of attempts to explain how we got here and whether or not we're alone. And most of them determined that we aren't. So it's no surprise to me that SETI research has captivated the hearts and minds of the public for decades, even if many of them thought that the Institute was just a figment of Hollywood's imagination, right? But tonight is not about science fiction. It's not even actually about science. It is instead about the people who do it. Tonight is about the people who have devoted their very impressive brain power to accomplishing SETI's mission. So over the next hour or so, we are going to be celebrating the achievements of 5 brilliant scientists at different stages in their careers. We're going to start with the SETI Forward Award, which is given to early career researchers who we hope are the future of the Institute. And then we're going to move on to the Carl Sagan Center Directors Award, which is given to a current SETI researcher who has made an incredible impact on the field. And then last but certainly not least, especially given the name of tonight's shindig, is the famed Drake Award. That is given to someone whose list of contributions to SETI rivals a CVS receipt. And I'm really, really excited for you to meet these amazing researchers and hear about their work. So without further ado, how about we give out some awards, right? Yeah. All right. First, we are handling the SETI Forward Award, which was created as a way for the SETI Institute to encourage and enable more young scientists to pursue careers in SETI and astrobiology. Establishing an endowment, Dane Glasgow, numerous other trustees, and the program's founder, Levy, made SETI Forward possible. Continuing support from Institute trustees Fritz Demopoulos and the sponsor of this segment tonight, Rima Khan, have enabled the expansion of this really popular program. And so, to tell you more about the program and to present the actual awards to you, I would like to welcome Levy and Rima Khan to the stage.
Everyone. Everyone? Yeah. Hi. So, welcome. It's good to be back here this year. So SETI Forward was established to provide support and encouragement to undergraduates interested in the fields of SETI and astrobiology. It was named to represent the research moving forward across generations and the idea that we are all better when we pay things forward. By providing an award and recognition to undergraduates, we hope to expose people earlier in their careers to the research in these fields, and even if they choose another career path, create SETI ambassadors who can relay the great work being done. For me, I got involved in SETI running SETI at home. How many of you ran SETI at home? All right. Well, that led to an opportunity to meet the people at UC Berkeley working at the Berkeley SETI Research Center and on the Breakthrough Listen projects. That is how I met Dr. Steve Croft, who is an astrophysicist with Breakthrough Listen at UC Berkeley and an adjunct senior astronomer at the SETI Institute. When I was early in my software development career, I had the opportunity to present at conferences and author papers, which greatly benefited my career. Steve and I discussed how he was working to send student interns to conferences, and the idea of setting up a program to sponsor students was born. Working with Andrew Simeon, Steve Bordeaux, and Steve Croft, we created SETI Forward, and eventually got an endowed fund to support the goals I mentioned before. Steve Croft was on the commissioning team for the Allen Telescope Array and has been instrumental in building up the collaboration between the SETI Institute, Breakthrough Listen, and the Berkeley SETI Research Center. Steve is excited about how these groups and how others have come to work together towards our shared goal of answering the question of, are we alone? I am pleased to have Steve join me this year to introduce a few of our award recipients. Steve?
Thanks, Lou. So our first recipient is Lana Tilke. She did her undergraduate at Connecticut College in astronomy, and she just entered the PhD program at Arizona State University, where she's working on characterizing exoplanet atmospheres. Lana's project was an example of that collaboration that Lou just mentioned between the SETI Institute and UC Berkeley. So she was supervised by Anne-Marie Cody, who's a researcher here at the SETI Institute, but based at UC Berkeley, funded by the National Science Foundation as part of the Breakthrough Listen undergraduate research program that I direct over at Berkeley. The NASA TESS satellite is looking for dips in the light of stars as planets pass between us and the host stars, but it can also find other things that are in orbit around stars. These could be disks of debris around young stars. They could be families of comets or potentially alien megastructures. Lana's project used machine learning to search for strange dips in these stars. And although she wasn't able to find any examples of extraterrestrial engineering on massive scales, her work is really helping us to understand anomalies in data sets like TESS, to understand where the limits of the weird are, and the weird and wonderful world of the TESS is opening up to us. I know Lana was very excited as part of our project that she got the chance to meet Jill Tarter on a Zoom that we had. And Jill is an inspiration, of course, to all of us. And I'm really excited to see folks like Lana and the other recipients tonight hopefully follow in Jill's footsteps. So congratulations, Lana. Very well deserved.
Hi, everyone. Let me just get this ready. So, as a child, I was captivated by the New Horizons mission to Pluto. When New Horizons launched, I had yet to even begin kindergarten. Still, I knew I will be an astrophysicist. I first became aware of the SETI Institute through their outreach, specifically the Kepler Planet Hunters and SETI Live Citizen Science projects. In that moment, my aspirations focused. I will be an astrophysicist at the SETI Institute. So, Bill. Last summer, through Breakthrough Listen's undergraduate internship program, I had the opportunity to work with Dr. Anne-Marie Cody. I created a machine learning algorithm to better identify anomalous fading events in test data. Why? To search for the technosignatures of Kardashev type 2 civilizations, of course. Dr. Cody, thank you for your guidance and support in this work. My experience last summer only served to reaffirm my childhood dream, and now I'm thrilled to say I've begun my PhD in astrophysics at Arizona State University. After graduate school, I hope to work as a research scientist, applying my exoplanetary expertise to the search for life beyond Earth. I will be eager to mentor undergraduate and early career scientists and pass along the guidance I am so grateful to have received thus far. Additionally, I plan to continue my artistic pursuits, advise science fiction media, and further explore the symbiotic relationship between science and the imagination. I want to express my heartfelt gratitude to Steve Croft for fostering the Breakthrough Listen REU and to Steve and Lou Levy for creating the SETI Forward program. I also want to thank everyone at the SETI Institute and Breakthrough Listen. You all made this an unforgettable experience. And lastly, I would like to thank my parents, Mom, Dad. I couldn't have done this without your unwavering love and support. Thank you so much.
So I'm glad that Lana brought up Pluto. If you all remember last year, that was a topic of interest for me. It still is. So, all right. So our next contestant, Benjamin Fields, interned at Wheaton College. His research focused on archival data, optical SETI. Specifically, he surveyed spectra taken by the European Southern Observatory's High Accuracy Radial Velocity Planet Searcher Spectrograph, HARPS for short, to see if it had captured evidence of laser communications from extraterrestrial civilizations. The premise being that since HARPS is not primarily used to look for intelligently produced signals, there may be unnoticed technosignatures in the archive data. Benji wrote an algorithm that searched for anomalous energy spikes in the spectra of 2,821 stars that flagged candidate signals for follow-up investigation. He compared these strange energy spikes to natural stellar emission lines, signatures of the Earth's aurora, and cosmic rays bombarding the CCD to ascertain whether they are natural or potentially extraterrestrial in origin. His stated goal was to share it with the technosignature research community, and the SETI Forward Award provided an excellent opportunity to do so. I would like to add that I have never seen a more creative award recipient, as Benji found the means to use this award to participate at the PSETI Conference, the Galileo Project Conference at Harvard Smithsonian Center for Astrophysics, and then stopped in Seattle to scope out University of Washington's astrobiology grad program. After all that, he still had money left over, which he used to offset expenses to join us here. So well done, Benji. So, Benji.
I'm so honored to be here. It's been a very surreal experience. And I say that because when I began the thesis project that ultimately brought me here, it was a wild gamble. I was just your everyday, typical absent-minded physics major who happened to want to search archival spectra for alien lasers. Only problem was, at the time, I couldn't code my way out of a paper bag. And to add to that fact, there were no established SETI specialists in my home department. The whole thing was the huge roll of the dice. My mind was split between curiosity and fear of failure. Well, I'm glad to report that curiosity won. All the wild, sleepless, caffeinated nights spent relentlessly tinkering with Python scripts, learning the ways of the algorithm and diving down spectroscopic rabbit holes seems to have paid off. To any students out there plagued by imposter syndrome, I simply say this: let this serve as an example. Let your curiosity be the passport to the universe's greatest mysteries, and don't listen to your self-doubt. Of course, I didn't get here alone. I'm very grateful to the Forward Award Committee for choosing my project. I'd also like to thank my advisor, Jason Goodman, who was willing to join me on this SETI adventure despite it being a bit outside his usual comfort zone. His technical genius and kind mentorship are unparalleled, and he really should be sharing the stage with me. I'd also like to thank my friends, family, and loved ones. There are too many to name, but if you're watching this, you know who you are. And finally, I'd like to dedicate this award to anyone and everyone on our pale blue dot who's ever looked up in the night sky and asked the question, is there anybody out there? If I can hope to achieve anything through this work, I brought us all a little closer to the answer. Thank you.
All right, so our third recipient this evening is Kendra Nguyen. Kendra worked with Doug Caldwell at the SETI Institute on a project that also involved data from NASA's TESS satellite, validating candidate planets using Python and visual inspection. And they found 20 new interesting planet candidates that are going to be followed up by ground-based observations So really kind of helping advance the mission of finding planets beyond Earth. Kendra is a senior at Pomona College, studying astronomy and politics, which I think is maybe a good combination if we do make contact with ET. Your skills may be needed. Kendra hopes to go to grad school to look at exoplanet composition. And congratulations, Kendra, another worthy recipient of the SETI Forward Award.
Thank you for welcoming me here tonight. It has been great to hear about why some of you all have been interested in SETI. For me, when I lost my mom when I was young, I looked at the sky and wondered if there was someone out there. Sorry, I'm gonna pull this lower. I looked at the sky and wondered if there was someone out there who knew the answers about grief and life. Today, I am looking to the sky for hope and looking to research for answers to my question. During my time at SETI, I was fortunate to hear Dr. Jill Tarter speak on the idea of extraterrestrial life as a sign that intelligent civilization can survive past adolescence. Coming from a first-gen low-income background, SETI is my hope that there is a civilization out there much more equitable than ours, where everyone has access to food and shelter and is free to pursue their curiosities. This hope is really what enables me to do my work as a politics minor and exoplanet researcher. I'm very curious about other worlds and what we can learn from them. As such, my work at the SETI Institute involved identifying planet candidates with the test observations. Planet candidates are objects that appear to cross in front of stars. These objects are classified as planets following additional ground-based observations from telescopes on Earth. Going forward to today, my work is focused on the planet confirmation part. I'm currently working with Dr. Heather Knudsen of Caltech to confirm and characterize 2 near Earth-sized planets that we suspect may host water and therefore be habitable. I hope to be able to share some good news with you all about these planets in the upcoming months. Preliminary results are already suggesting that these planets may have a little more than just water. Until then, thank you to Dr. Matthew Tiscarino and Donna Richardson for hosting the SETI RAU program. I'm grateful to Dr. Douglas Cadwell for his amazing mentorship. And lastly, thank you to Rima Khan, Lou Levi, and Dr. Steve Croft for making this award possible.
Awesome. Let's give another round of applause to all the SETI Forward winners. Yeah. Everything they do is great. I mean, they're the future of the field. They can do no wrong. It's adorable. I love it. One of the most impressive things about SETI to me is that their research or fascination with their research isn't reserved to just scientists. The search for life can inspire awe and wonder in everyone from children to accomplished business folk. And so before we move on to the Carl Sagan Center Directors Award, we have a very special presentation to honor someone whose support of SETI really rang from their heart. So I'd like to invite Bill Diamond and Chairman of the Board, Dan Lankford, up. Let's give them a round of applause. Yeah.
Thank you, Moiya.
Oh.
How about another round of applause for those amazing undergraduates? So impressive. You know, I think back to what I was like at their age, is like, oh my goodness. Couldn't even stand in the same room. Unbelievable. So wonderful and so proud of you, and so appreciative and so hopeful for your futures. So as Moiya said, you know, science is not just about those who practice it, but also those who support it, those who are interested in it, those who benefit from its output. And we are, of course, surrounded and filled in the SETI community and the space exploration and space science community with people just like that. So we have a special recognition that we want to discuss briefly tonight. It's a somber moment on the one hand, but it's also a recognition and a celebration of those who support the work that we do. So for nearly 5 days in mid-June of this year, people from all over the world held their collective breaths over the fate of 5 individuals apparently lost on a submersible vessel called Titan during its descent to visit the Titanic shipwreck. Of course, we were all mindful of the ongoing triumphs and tragedies of the human existence that continued to unfold during those 5 days. But nevertheless, the plight of these 4 men and 1 young man had all of us clinging desperately to the hope of some miracle for their rescue. We subsequently learned that all 5 people on board the Titan were lost on the very first day of, as a result of a cataclysmic implosion due to the failure of the vessel's pressure hull. One of those on board was a SETI Institute trustee, Shahzada Dawood, and he was accompanied by his 19-year-old son, Suleiman, and we sadly lost them both. So Shahzada brought his considerable skills, his business acumen, his irrepressible curiosity, his childlike curiosity and sense of wonder to the SETI Institute's board. In marking our collective loss at his passing, the Board of Trustees authorized the establishment of a new ward of service at the SETI Institute at its July board meeting to recognize those who give of themselves in support of the Institute and its mission. The first Trustee Service Award is granted posthumously to Shahzada Dawood for his many trustee contributions. We're honored this evening to have with us Shahzada's widow, Christine Dawood, and their daughter, Alina, both of whom traveled all the way here from London just to be with us and to share in this moment tonight. So Christine, if you would be kind enough to just come forward and take the stage for a moment to accept this award on Shahzada's behalf, we would be honored. And it is with the heartfelt condolences of the Institute, its Board of Trustees, our many friends and families, it'd be my privilege to present this to you.
Let me read the award, if you will. In appreciation for his service to the SETI Institute, support of its mission through his passionate curiosity, his philanthropy, and his membership on the Board of Trustees. The Institute is honored to bestow its 2023 Board of Trustees Service Award to Shahzada Dawood, presented to Christine Dawood this 14th day of September.
Thank you for your courage and for being here with us.
Thank you so much for being here, Christine, and thank you, Bill and Dan. I think one of the reasons that SETI's work is so fascinating to so many different types of people is because we all trust it to relentlessly pursue the truth. And that quest is carried out by the researchers at the Carl Sagan Center, which is home to more than 100 principal investigators working in 6 different areas of research, and they're all very cool. Go check out the website. While everyone at the center is a rock star, the Institute would like to honor one extraordinary scientist tonight. So to present the 2023 Carl Sagan Center Directors Award, I'd like to welcome Dr. Thomas Zurbuchen to the stage. Dr. Zurbuchen is the former Associate Administrator of NASA's Science Directorate. It's a big wig. And I'm told the person to hold that position for the longest amount of time. So welcome, Dr. Zurbuchen.
I'm so honored to be here. I'm one of the people who's here for the first time. So I will see. Do I get an invitation next time? It probably depends how long I'm speaking now. So look, you asked me to talk about fundamental research, and I wanted to tell you that for me, fundamental research is about 3 things. It's about curiosity, it's about hope, and it's about thrill. It's important to never stop questioning. Curiosity has its own reason for existing, said Einstein. And it's frankly easy to understand curiosity. You just have to hang out with children. They will start asking questions about nature, about things they don't understand, and frankly demonstrate an understanding and an interest in some of the most simple things, such as everyday occurrence of a blue sky. Why is it blue? And I'm like, don't ask me that, it's really hard. The question is, are we losing that curiosity or are we keeping it? So I never knew Frank Drake in person, and I got to know him through his wife, Amal, who's here, and his two daughters, especially my friend Nadia, with whom I did some presentations celebrating the important work of Frank Drake. If there's anything I learn about him, is that he kept that curiosity all his life in a way that's almost childlike and kind of with an excitement that frankly is infectious even after he has left. I still see it in his family, but also in his important work. Don't stop being curious. That's really important. Well, as you grow older, you meet people that tell you that they are realistic. And they ask you, and frankly, NASA asked me almost every interview, since we have all these problems on Earth, or in the state of Michigan, all these broken roads, why would we invest in fundamental research? We invest in fundamental research because that's an expression of hope. It's not just because of the problems today. If all we had to focus on are the problems of today, we would, with giving up on research, give up solutions, kind of excitement that will tomorrow solve problems that we don't even know. There is no better story of that than the one we experienced in 2020 when a virus changed our lives. And the research in the labs that was already there were solutions that changed, again, the entire world. Solutions that were there that came from research. Solutions that were put together through hope. Working at NASA on many of these missions, including the James Webb Space Telescope or Perseverance or even a little helicopter on Mars, I know that a lot of this has to do with hope. When you start, frankly, you know it's going to be really, really hard, and the likelihood of success is not 100%. You start with a team that has never done it with a hope that that success can be there. And as I look at the James Webb Space Telescope images that are showing up, I think of hope. I look at the sky today. I think of the hope of the teams that imagined these missions and the beauty of the sky that is manifested in these images. And I think of the telescope yet to be built, yet to be imagined, doing the same. But it's not just hope. When you work with these people, you see something that is absolutely exciting, and you see it each and every day. It's the thrill of doing something that's absolutely hard and almost impossible to do. It's that thrill, it turns out, that Robert Goddard, the famed rocket pioneer, wrote in a letter to the sci-fi author, H.G. Wells, in 1932. Here's what he wrote. How many more years I shall be able to work on the problem, I do not know. I hope, as long as I live, there can be no thought of finishing, for aiming to the stars, both literally and figuratively, is a problem to occupy generations, so that no matter how much progress we make, there is always the thrill of just beginning. Yes, research is a never-ending thrill of just beginning. So I'm happy now to introduce Dr. Nathalie Cabrol, the director of the Carl Sagan Center, for her presentation of the Director's Award for Outstanding Contributions of Institute Science. Thank you so much.
Thank you, Thomas. Good evening, everybody. As the chief scientist of the SETI Institute Carl Sagan Center for Research, I have the privilege to interact daily with some remarkable scientists. Truth is that the SETI Institute is the home of some amazing diversity of researchers who work tirelessly to search for life in the universe, be it a microbe or a technologically advanced civilization. We connect disciplines to try and detect signatures of life in the solar system and beyond. And this gives us a unique insight into the thresholds of planetary habitability, including on our home planet. From radioastronomy to astrobiology, from climate to biogeosciences, and from planetary exploration to whale communication, our scientists are writing some of the greatest pages of the search for life in the universe. Among the scientists is Dr. Uma Gorti, the recipient of the 2023 CSC Directors Award tonight. Uma, I've known you for quite some time now. You were a National Research Council Fellow at NASA Ames just a few years after I finished my own tenure as an NRC Fellow too. And you have been at the Institute since 2008. Your background in physics with a PhD from the Indian Institute of Astrophysics in Bangalore in 1999, and your research encompasses, among other things, astrochemistry, star and planet formation, protoplanetary disks and their evolution, interstellar medium, and gas dynamic and transport. Now, I know someone who is going to be really having a ball with the new James Webb Telescope data. But you are not just using this data from the James Webb, you are actually helping guide its future research. Among the many projects you are leading or are involved with, I especially noted those who are preparing the ground for the James Webb to understand better how planetary disks evolve into planet and how to follow the trail of water from the interstellar medium to potential habitable planet. You are at the very beginning of this search for life in the universe when we are creating planet and when they are becoming habitable. Your accomplishments as a scientist are great and many, but it's only part of the reasons why you're a recipient tonight. Your name has come repeatedly amongst your peers for this year's nomination, and the decision was obvious to all. While this award is richly deserved for your research, it also acknowledged your work as an outstanding mentor for the next generation of scientists. You have advised dozens of master and PhD students, been a mentor for REU undergraduate program for the past decade, mentored many NASA summer interns, and contributed to countless outreach activities, including providing research opportunities for high school physics teachers and students, devising hands-on experiments for school students, and encouraging STEM activities in many ways. Last but not least, I would like to thank you for being always ready to step up when and help every time help is needed, just because this is a person you are. And for all of us at the Institute, beyond the respected scientist you are also a beloved colleague. So Uma, congratulations again on behalf of all of us at the SETI Institute for this richly deserved 2023 CSC Directors Award.
Not chocolate. Not chocolate.
And this is for you too. Again, I'm going to remove this. There is a little something in addition to the certificate that you might find interesting too. And this is for you on behalf of everybody at the SETI Institute. Thank you so much for what you are doing.
Thank you very much. So thank you, Nat, for that lovely introduction. I'm deeply honored to and proud to be here today. I don't have words to say how I feel. I've been at the SETI Institute. It's like a wonderful place to work at, and you have all the freedom that you could want and all the support that you could need, and amazing colleagues you work with every day who do incredible work. And so it makes me all the more, this means so much more to be recognized for the work that I do. I think the only words I have here is I'm just incredibly lucky, I guess. And so I've been that way. I think the whole career has been sort of a series of fortunate events, if you will. I've had a lot of freedom right from my PhD days to sort of pick what I wanted to do. I chose my own research problems. And then I came here to NASA Ames and for my first postdoc. and I work with David Hallbach. And for those of you who don't know him, he's a legend in the field and absolutely the best mentor you could hope for. And I'm fortunate to still be working with him today, although he's been retired for quite a while. And we joined the SETI Institute, or I joined the SETI Institute about almost 15 years ago now. And way back then, part of the job interview was to meet Frank Drake, and then you had to explain to him how your research fit into the Drake equation. And so this was, and actually that's a great introduction to, it's a really excellent introduction to the topic that of research that I work on. And actually, so my research is concerned with the first two terms of the Drake equation, which is R star and FP. And so my earlier work was basically based on R star, which is the rate of star formation, which is what I did during my PhD and also during my early postdoc years. But then, stroke of luck, so there was no Spitzer had launched, and there was this time that was just right, and and right after I joined the SETI Institute, Kepler launched, and all the amazing things that came out of all that. And so we moved to disks from star formation. So this is sort of getting to FP, the second part of the Drake equation, right? And that sort of is captured by, I don't think this mic's working. Is it? It is? Oh, you can hear, oh, all right. I don't need to stand there. I think I like that, sorry. Yeah, so so these sort of, the slide here represents those two terms of the Drake equation, R star and FP, and it's easier to look at the right, and that's the amazing diversity of planets you have. This is a cover for a magazine a long time ago. And you can see that, we have planets out there that we've discovered that are nothing like our solar system. So there's this enormous sort of diversity in planets. And to get to the third term in the Drake equation, which is NE, and which is, how many of these can harbor life, you really need to understand, what sort of planets form, where they form, and, and sort of what determines how they form. So unfortunately, what you need to do for that is to look at a very early stage in to go back to their birth environments, and that is represented by this plot here. This is actually a wonderful JWST NIRCam image of a famous protostar. And so you can see out here, I don't think this is working, but the little black band in the middle there, that's the disk. That's a really cold material, and that's where the planets form. And that's 1,000 AU, which is the Earth-Sun distances. So you can see it's really small. Most of the plot is being, it's the outflow, it's a spectacular outflow from the star, many thousands of AU wide. And this is the star sort of putting out all this enormous energy. And so because stars and planets actually form together, so which means that most of what you have to look at is enshrouded in all this material, and you have these spectacular images, but what you're really interested in is that little disk out there. So there's a little disk that sort of first makes the star and then makes planets. And that's what you're trying to look at to figure out, how do you get the diversity of these, the diversity that you see here. And so because the disk is so cold, well, we have another fortunate event. So the 2011, around the same time, was also when ALMA went up. So ALMA is a subalbedo array in the Andes, in the Chilean Andes, and it's sort of, well suited to looking at these really cold disks, which is where all these planets are forming, hidden from our view. And that has also revolutionized, what we learn about this. And we find that disks are equally diverse. I mean, it's not just planets. I mean, you can see that the birth environments are diverse. And part of what I do is, the focus of my research is trying to sort of connect the two and trying to see, well, what is it about these disks? So what are these conditions that then give rise to those planets? And so this is one of the gallery of ALMA images. This is looking at the solid components. So these are little dust particles that get together and, eventually, like, sub-micron size sand particles, if you will, that have to grow and stick to become planets that we see. And you can see here that, you could suddenly now look at these disks and you knew what was happening in. And a lot of these rings or gaps that you see are believed to be planets. I mean, there are other explanations, but it's possible that a good deal of them are planets. And in fact, what has been one planet that's actually been discovered in a gap, sort of lends support to this idea. And it's not just that, you can look at the physical and chemical conditions in the disk, what kinds of environment, what are the kinds of environments that these planets are forming. And this here is another ALMA legacy a program of 5 disks. And what you can see here is you can look at these species. And if you look at the top 5 disks, you're looking at the same species. In this case, it's hydrogen cyanide. It's, and different molecules and different atoms sort of get excited at different conditions and emit at different conditions. So you have to kind of piece that together to see what the disk looks like. And you can see that at the top, we have the same molecule looking, there's enormous diversity in how that's distributed spatially all over the disks. And in the bottom panel, you have the same disc, but you're now looking at it in different species, and that's equally diverse. So, so one of the challenges we have in all of this, of puzzles really, is to see, how are we going to put that together, and how are we going to determine, how to sort of make sense out of all of this. And I am actually a theorist. I'm not an observer, although I would love to show all these observational images. They're inspirational. But I sort of do, number crunching and I construct mathematical models of these things. And we try to figure out, what's the physics and what's the chemistry that then gives rise to something like this. And that really is captured in this last slide that I have. It's sort of a representation. It's a schematic of what that disk looks like and the sort of things that we try and, we have figured out and things we're trying to figure out. And here, like you can see on the left side, you have all these little small dust particles, which are growing, they move, they collect material, and they sort of then determine the composition of planets that form in there. And they sort of are just, they move radially and vertically, and those are the, the building blocks of rocky planets. And material then accretes onto the central stars, that's what you see in the middle, and this material also being transported towards the star, it gets dumped on it, and then that gives out, that generates a whole lot of energy, as you might imagine, UV and X-rays, which then hits the surface of the disk and then drives all this chemistry, and it actually heats the disk, it drives flows. One of the first things that I worked on was these photoevaporative flows. We disperse the disk. And then what's not shown here, of course, there's also magnetic fields complicating the whole situation, and they actually help transport angular momentum, drive material, they generate turbulence in the disk, and they also drive that rather spectacular NIRCam image that you saw right in the beginning. So those are outflows driven by magnetic fields. So we've, so basically it's a big mess, and so it's fun for theorists because you can sit there and sort of advise what's going on. And now we have JWST, and there's going to be another flood of information, probably keeping us busy for years to come. And so I have fun doing what I do, and I think I'm fortunate to be able to sort of study problems like this. And yes, and of course, thank you all for the award. I would like to thank the committee for recognizing my work, and I'm the sponsor, and Matt for the wonderful introduction that you gave me. Yeah, so thank you very much for being here.
We're going to pose for a photo op.
Any questions? How many took notes? So a little surprise, there's going to be a quiz, and you have to get a C or better in order to get coffee and dessert. So that'll be passed out just momentarily, and good luck. But thank you, Uma. This work is truly exciting. And again, it reminds us that this is, the universe we live in is a dynamic, not a static environment. And all of these processes are happening, and they have happened, since the very beginnings of the universe, and they continue to happen and evolve. So it makes the work very exciting. I asked this young lady to stay with me up on stage here for just a moment. She doesn't know what's about to happen, which is what makes this so much fun. But at the Institute, we initiated a few years back what we thought was an appropriate recognition for members of the scientific community, members of the SETI Institute community in the fields of education and research and outreach and communications. Those who have excelled, those who have worked for many, many years at the Institute, who have contributed at a level of excellence that is just above and beyond expectation. And their dedication and perseverance, their passion, their sense, as Thomas so beautifully put, of curiosity, of hope, and of thrill is embodied in what they do each and every day. So we created what we call the Fellows of the SETI Institute, which is the highest honor we bestow upon our own members. And Nathalie's own peers recognized her to be the next fellow of the Institute. Sorry, kid. But she joins Edna DeBoer, who's with us tonight. She joins Dr. Seth Shostak, who's not with us tonight. He's in Greenland giving lectures on a ship, but not the one that's stuck in the fjord. You may have heard about that. And she joins Dr. Mark Showalter, who was one of the senior scientists involved in the New Horizons mission. Actually, he was the head of what was called the hazard avoidance team, and his efforts led to the discovery of Kerberos and Styx, two previously unknown moons of Pluto. So she's joining quite a group, and we're so proud and honored to have Nathalie in our midst. And among other things, one of the recognitions we have is on the walls of the Institute, which you're all welcome to come and visit. All you have to do is pay the admission fee, and are hung portraits of our members. So. And just to tell you how magnanimous she is, what she just said to me was not, thank you very much, but rather, you're going to pay for this. Great. All right. Congratulations. You're welcome.
Congratulations again to Uma and Nathalie, two powerful women at SETI. I love to see it. I really do. How are we doing? I know it's been an evening of excitement already. Is anyone else feeling a little warm? Or is that just like the mood of the evening in getting hotter in anticipation of tonight's titular award? Are we very excited for the Drake Award? That's coming up. Yes. For those of you who don't know, the Drake Award was named after Dr. Frank Drake. And this is sadly the first ceremony since his passing last year. But we are really happy to have Frank's daughters, Nadia and Leila, and Frank's widow, Amal Drake, with us today. I think you're all over there. Hello, thank you. Yeah. And so now, to illuminate Frank's leadership in establishing the field of SETI, we have a short video to share as we prepare to recognize the 2023 Drake Award recipient. So enjoy the video.
This array of antennas, situated in the Cascade Mountains of Northern California, is not tracing the interstellar gas of our galaxy. It's not imaging objects like pulsars, quasars, or the neighborhoods of black holes. It's searching for evidence of intelligent extraterrestrials, aliens. This endeavor is known as SETI, the Search for Extraterrestrial Intelligence. It is a daring experiment that could forever alter humanity's view of itself. An experiment to use modern technology to find other galactic inhabitants was first attempted by a soft-spoken astronomer named Frank Drake. Born in Chicago at the start of the Great Depression, Drake was interested in chemistry and electronics. He enrolled at Cornell University and was part of a Navy officer training program. After graduating, Drake was put in charge of electronics aboard a Navy cruiser, the USS Albany. In 1955, he entered Harvard as a radio astronomy grad student. After receiving his degree, the young Frank Drake joined the newly minted National Radio Astronomy Observatory in the Soft Hills of West Virginia. The observatory had just purchased an off-the-shelf radio antenna sporting an 85-foot dish, and Drake, the new guy in town, was encouraged to think of experiments befitting this instrument. What followed was a 2-month observing program he christened Project Ozma after the fictional Princess Oz in Frank Baum's book. In an experiment that discomfited some astronomers, Drake used the antenna to look for radio signals coming from the directions of 2 nearby stars, places that could conceivably house planets with intelligent beings. He wasn't studying natural processes, but looking for emissions launched into space by an extraterrestrial society. He didn't find any alien signals, but Project Ozma had generated a tidal wave of interest. A year later, Drake was encouraged by the National Academy of Sciences to convene a small meeting of a dozen scientists to weigh the odds that we could find aliens by eavesdropping on radio transmissions. The meeting was held in the fall of 1961 at the observatory where Drake had done Project Ozma. As agenda for the meeting, he wrote a simple equation on a blackboard that would estimate the number of on-the-air societies that exist in our galaxy. This agenda, now known as the Drake equation, has been called the second most famous equation in science. Thus began the modern era of SETI. Drake had planted a seed that has sprouted into several signal searches in progress today. These efforts are constrained not by a lack of technical expertise or astronomical knowledge, but by a shortage of funding. SETI is run on monies donated by a handful of interested individuals.
We will need to search through literally at least millions of stars to give us a good chance of finding a signal from another civilization.
SETI experiments have not yet found proof of extraterrestrials, but a small number of scientists are continuing the search with new observation programs and the development of new receiving equipment. By 2035, these experiments will have reconnoitered about 1 million planetary systems, an impressive sample. So it's conceivable that Drake's audacious experiment will soon pay off, that we will learn that humans are not the only intelligent species in the cosmos, that we share the universe with others.
Gosh, I sure hope so. That would be nice. I remember the first time I heard about Project Ozma, and I thought, what a weird and brave thing to do, to search for these signals when no one else thinks that it's going to work. And I'm so glad he did, and I'm so glad that other people have continued that work. I'm told that Frank often spoke at past Drake Awards, giving the last word and inspiring us and filling us with wisdom. And we're certainly going to miss Frank doing so this evening, but we are happy that Frank's daughters are going to speak in his stead at the end of the ceremony. But first, get ready to meet the accomplished and, as I learned yesterday, charming recipient of this year's Drake Award. And so if I could please invite Bill Diamond back on stage to present, then we will meet the man of the evening. Yeah.
All right. So sadly, I assume I'm not the charming guy you were talking about. It's somebody else. Oh, okay. All right. Wonderful. Super. So this is the moment we've all been waiting for. The SETI Institute's Drake Award celebrates exemplary contributions to SETI and astrobiology through scientific research and space exploration. The award is named in honor, as we know, of its first recipient, Dr. Frank Drake, whose equations identified the various factors necessary for the emergence of life in the universe and the evolution of technological civilizations. This honor is given at the discretion of the Board of Trustees of the SETI Institute, and it's based on the recommendations and nominations of our Science Advisory Board. Past recipients have included Nobel laureate Charles Towns, Kepler Space Telescope principal investigator Bill Borucki, astrobiologist Vicki Meadows, SETI pioneer Jason Wright, who's with us tonight, Dan Werthimer and Paul Horowitz, among others. So we're delighted to be honoring tonight's special recipient. So we're honoring tonight a gentleman who's devoted his entire career to advancing the search for intelligent life beyond Earth, for understanding the parameters associated with the emergence of even the most basic forms of life, and for being among the pioneers in the field of planetary protection, looking to both protect those worlds we visit and to protect planet Earth from materials we might bring back from those worlds. Dr. John D. Rummel received his PhD from Stanford University in Biological Sciences in 1985, following service as a naval flight officer in the U.S. Navy. Most of the next 20 years were spent with NASA, both here at the NASA Ames Research Center and at NASA headquarters. He was a professor of biology, among multiple other assignments, at East Carolina University for 7 years, a visiting scholar at McGill University for 4 years, and also served as an adjunct scientist in the Marine Biological Laboratory at the Woods Hole Oceanographic Institute. And most importantly, John served as a planetary protection scientist and policy advocate at the SETI Institute, supporting planetary protection at NASA headquarters from 2015 to 2020. And he also served as a consultant to the Institute for 5 years before that. John has membership in a number of professional societies, including the American Association for the Advancement of Science and the American Geophysical Union. He's been a recipient of innumerable honors and awards, but clearly none as memorable, as meaningful, or as important as the Drake Award. So before we asking John up on stage, we'll let him tell his some of his own story in this short video presentation.
I'm John Rummel, and I'm interested in biology, ecology, and space. From 1986 to 1993, I worked in Washington as, among other things, the program scientist for the NASA's SETI program. That program, which featured the MOP, or Microwave Observing Project, was an ambitious effort to find evidence of extraterrestrial intelligence in other star systems. The idea was to use some of the world's largest antennas to try and eavesdrop on signals produced by an entity that was both intelligent and technically accomplished. We knew that while there might be some sort of life elsewhere in our own solar system, if we wanted to find intelligent life, we'd have to look farther away, much farther away.
The NASA SETI program was two-pronged. One component, called the All-Sky Survey, would listen for signals coming from any place in the Northern Hemisphere sky. The second component, known as the Targeted Search, would intensely look for signals coming from any of the star systems within about 200 light-years of Earth. Several large radio telescopes were used in this program in Australia and in the US.
If there are aliens on a nearby world, this project might find them. Even though this program was the most ambitious search for evidence of aliens ever undertaken, it was still a relatively small-scale effort. It cost about 3 cents for each American taxpayer. Sadly, the fall of 1993, Congress canceled the MOP, by then renamed HRMS, the High Resolution Microwave Survey. NASA's SETI project was dead. But SETI wasn't. The private, non-profit SETI Institute in California picked up a lot of the NASA project, and the hunt for extraterrestrial signals went forward. That work continues today, with multiple efforts to find proof of other intelligent life in the galaxy. If we find that proof, a signal, a technological artifact, or some other bit of evidence that someone is out there, that will be one of the most important discoveries in the history of our species, and perhaps in theirs too.
All right. That's a great introduction. And to help honor and celebrate this year's recipient, I'd like to ask our chairman of the board, Dan Lankford, to come and join me on stage. I'd also like to ask Thomas Zurbuchen to return to the stage and help us celebrate John. Dan, I'm going to give you this not as the recipient, but as the, the hander. Thomas and I will do the medal. And now, the gentleman previously referred to as charming, John Rummel, please come on up.
I will listen attentively. I saw you applauding your own video before. I just wanted to encourage that guy not to jump. So, the Science Advisory Board and the Board of Trustees of the SETI Institute are pleased to present the 2023 Drake Award to Dr. John Rummel, our friend, colleague, for his lifelong contributions to the field of astrobiology, his leadership in the domain of planetary protection. We're still here, so that worked out pretty well. And
so far, so good.
So far, yeah, good point, Tom. Good point. And his years of service to both NASA, the SETI Institute, and this is presented this 14th day of September, 2023, and well deserved. Thank you, Kendra. Oh, look at that. Yeah. Thank you, Kendra.
He wants to see the medal.
You want to see the gold medal?
There you go.
Here, I'll hold that for you.
Block off the security.
And John, just as further expression of appreciation from the scientific community that makes the Drake Award possible, a check for $25,000.
Even better. Thank you.
John will now present his PhD thesis dissertation. It's 1,000 slides, and there will be another quiz following this. Thank you. John, take it away.
So in 2020, my family and I were in a very nasty car accident that you see pictured in front of you. And we found ourselves in Billings, Montana without a ride home and some difficulties associated with injuries to my wife. And the kids were happy to play in the playground. Thomas picked it up and retweeted something that Keith Cowing had done. And we've always been very thankful for that, Thomas. So thank you. Curiosity, hope, thrills. What could be better than that, except for good management coming along with it? So I want everybody to understand that, you know, from my perspective, you should take the opportunities given to you, do something good with them, and be able to explain it to people why you did that, but to do it on everyone's behalf. So listen to the scientists and engineers who you work with and who work with you in turn. Make sure that you know what you're doing when you do that, but also be able to defend it when colleagues find you doing something that they wouldn't have thought about. And many times in my career, people have said, you can't do that. And many times I've said, that's exactly what I'm going to do. So it's worked out pretty well. But hope, thrills, curiosity, what spells that better than our friend Flash Gordon? So this is where I came in. This is what they use for STEM education in in the 1930s. So I really decided, based on Dr. Zarkov, that I wanted to be a space scientist. And it was a very good idea. And I will tell you that Dale Arden had nothing to do with it. Now, this is a slide that I like particularly for this presentation because Frank and I shared this Navy background. I flew out of Moffett Field. It was just another way to come in and work for NASA Ames. But we had a couple of good things that we could do. We could chase submarines using a video game that the Navy put together with you, and you didn't get drafted. So it was really a nice opportunity. Now, I wanted to caution all you guys who work in Silicon Valley software that Gary Larson didn't figure that this was actually true, but it is true. You can pay video games now for a lot of money, and the parents are very happy with that. Thank you, Tristan. Anyway, when I went to Stanford to put some polish on my aspirations, it was a great deal in the biological sciences, had a number of notable professors, et cetera. And we got to work on a PDP 11, 1134 for those of you who are paying attention, and a Cray XMP, which is at the National Magnetic Energy Fusion Computer Center. So it's able to do that, and then they eventually let you publish stuff about that. And I should point out that the mountain in the upper right is a mountain that I climbed before it erupted, and I had nothing to do with the eruption. But we studied the little lizards that are up there, and they have a lot to teach you about biology, but not about extraterrestrial biology. But I got to publish some of that, and the field work in the Caribbean was something that was, you know, what not to like. I lived on a sailboat, we went on little keys, we spent the day, we came back, we talked about our results over rum punches. It was a pretty good life. But at some point in time, they make you leave. So, I mean, this is a Stanford policy. Once you get your degree, you can't stay around in Escondido Village anymore. So off I went to NASA Ames. There's a Life in the Universe course that NASA Ames used to give, and they still give on the Stanford campus. I met Jill, I met a number of the other people. And they said, well, you should look into this. And the guy by the name of Jim Lawless said, you know, welcome, John, this would be a really great place. And I said, well, I'd really like to do life support. They said, well, that's down the hall, and we can do what you can. And I ran into Bob McElroy and Mel Avener, and they were interested in terraforming Mars. I was interested in terraforming Mars, or at least making Mars jars that you could live in, i.e. life support systems. So that was kind of fun. And
published some good work. People were excited about this work, so excited that they said, "You don't want to be a scientist anymore, John. You want to come to NASA headquarters and work there." And I said, "Oh, wait a minute. What do I get to do?" And I said, "Can I work in biospheric research? Sure. Can I work on flight crew factors? Oh yeah, life support, no problem." But when I got there, none of that was true. They said, "You know, you'd be really good if you could run the exobiology program, because the guy who's running it now is going to NASA Ames. It's like a swap." But I was only a postdoc, and it was one of those things that, you know, normally they don't give postdocs $6 million a year and good for it. But Lynn Harper was there, and a variety of other people had made that case. And eventually I was able to turn over this program in 1993. But these guys had all run NASA's program in exobiology, as well as their program in looking for life on Viking. For example, Dick Young on the far left, Don DeVincenzi, me, Michael Meyer. So all the things that NASA wanted to do, but didn't know what to do with them, they gave it to me. So that was a lot of fun. Even stuff like biomass burning. When we first were looking into this with the folks here at Ames, also Joel Levine at Langley, there were a bunch of people in the community said, "Oh yeah, that can't be very important." I said, "Why can't it be important?" Because it wasn't in George Woodwell's picture. And we said, "But there's an atmosphere out here, and it burns and it puts up toxic greenhouse gases. Isn't that interesting?" "Oh, okay, you think it is." So we ended up showing the people of the Department of Interior how to use remotely sensed data to fight forest fires, and they were very happy with that after that. Now, the Life Science Division was a very strange place because they were building a space station in NASA, but they weren't necessarily putting life sciences into it. They didn't have enough money to do that. It was a very odd kind of relationship. And of course, between wondering what's going on in the rest of the world, et cetera, and wondering about why astronauts throw up in space, you know, it's a good line for Jake Garn, who wasn't a happy camper as an astronaut. But the bottom line is that we were very lucky to have such a wide span of information. And when we started to work with other people, I tried to make sure that the advisory committee for the Life Sciences Division understood that there was more to life sciences than they would want to receive. Anyway, so the dark side of life sciences and large impact events, there are major impact craters, and they've all had something to do with the change in the evolution of life on this planet, and other planets probably too. Anyway, we could go ahead and, you know, have the SETI microwave observing project. I remember describing it to the associate administrator at the time. It was a high resolution microwave survey of solar type stars with attention to solar type stars. He said, "Well, that sounds scientific." I said, "Well, yeah." Anyway, so we were able to go. We had very good support from the folks at the White House, which was helpful. There were strange things going on in NASA at the time between the White House and NASA and who was going to do what. And somebody who had been the deputy director or the deputy administrator of NASA had been moved to be the chief scientist, et cetera. In the long run, they said, "Do this project." We said, "Okay." I wasn't always appreciated. And of course, the gentleman here is speaking to a lamp, trying to explain to them about life in the universe. It's not all that bad, because I actually would have spoken to a lamp if they could have voted for us. And in many times, at one point I was walking through and we were talking with some Russians. I'll touch on that later. And I had a little cube of aerogel in my pocket. And I pulled it out, and one of the aides there goes, "Rummel, you're nothing but a huckster." You know? And I said, "Yeah, a huckster that can catch cosmic dust is not a bad thing." Anyway, along the other lines of what I was interested in do, I found out that there was this job. It wasn't everyone's job. In fact, it was my job. So thanks to Perry Stebakis, I was able to survive going in. Carl Sagan, Josh Lederberg, all very pioneers in the field. They were able to go ahead and make me rational as far as they were concerned. I was let out to go on my own. Perry was a great guy. And of course, planetary protection involves preventing forward contamination, where we go out and contaminate all the other worlds and then discover later that there's life there. Big surprise, because we took it ourselves. Oh, and back contamination, as Bill mentioned, so we don't bring back something that will kill us all. And this isn't something that you really should depend on expert advice, because nobody knows anything about extraterrestrial life in terms of, there are people who say, oh, it should be just like us. And in fact, I'll stake my life on it. But of course, they're hoping that they're not wrong. And when you're dealing with the 8 billion people on the planet and you can kill them all with the wrong thing brought back, you want to be a little careful. So anyway, we do that. Most project managers can't see microbes, so we developed a course to show them what a microbe looks like and let them play with microbes. Vibrio fischeri is a great glow-in-the-dark microbe. So if you can get some of that, you can have fun. And of course, Bart Simpson was the guy who really inspired all of us, that science class should not end in tragedy. So if we're going to go forward in the world, let's not destroy it. Anyway, nobody should have to worry about that, but Bart was a great guy. I'm going to run through some of these, but these are the things that I did that I was proud of. I kept on thinking of new things, even some things that I wasn't proud of, but I didn't put those in there. The bottom line is that there are many opportunities that people can take. I took some of them. I didn't have to take all of them, thanks to some great colleagues at NASA headquarters. But things like, how do you talk to the public? Well, we had a National Air and Space Museum exhibit, What Next Columbus, where every one of our branch programs was highlighted due to the work of Dale Anderson, a member of the SETI Institute, and Valerie Neal, who was the curator. We did all sorts of things. We established a NASA specialized center of research and technology to study the origin of life, that are known as the San Diego group, and then there was one in New York as well. That sort of thing was really fun. We kept working on plants in space, and now they have a veggie system on the ISS where people can actually eat something that goes crunch as an astronaut, and they really like that. We work with the Russians in a joint working group in space biology and medicine. I was the chair of one implementation team called the exobiology implementation team. A big surprise that. But we founded, together with Valery Kubasov there, a life support implementation team so that we could work together on things with the shuttle program and the Mir program. And we eventually had a big collaboration in Shuttle Mir. And Valery Kubasov at first thought I was a CIA agent, thought that my interpreter was a FBI agent, and it was a great time. His second in command came the next time, and we drank a lot of vodka. And the next time I saw Valery Kubasov, his wife gave me a big hug. I was like, okay, I'll drink vodka if that's what it takes. So anyway, the gas gradient simulation studies haven't been implemented. I'll take a look at the new decadal survey that came out today to see whether or not we can shoehorn it in. But the Stardust mission was based on technology that the Life Science Division funded, because the people at Johnson Space Center didn't believe it could be useful. But Peter Sue at JPL did some great work with the people at Lawrence Livermore and got that technology available. Let's see, COSPAR was an interesting time. What I did, I'd updated a bunch of the requirements, et cetera, so that instead of not being able to run a rover on Mars or a helicopter, you could actually do that. And eventually I proposed the COSPAR panel. COSPAR is the Committee on Space Research. It's an international organization that's got a long variety of national members, and some international aides are part of that, 13 of them. And anyway, COSPAR advises the UN, among other things, and provides for a consensus international policy that everybody can follow that will allow them to agree with each other as to what they're going to do to protect other planets and the Earth. So I got that done in 1999, based on a proposal in 1998 that was at a COSPAR meeting, and the Japanese guy stood up and said, we're going to orbit for 2 years and then we're going to crash it. And I said, well, I don't think that's a good idea for Mars. Maybe you should not crash it. And we eventually ended up working with them so that even though the mission itself failed, it didn't crash. So we'll see about that. One of the more fun programs, of course, and the one that got me to South Pole was the Antarctic Space Analog Program. Get the acronym ASAP. The last place on Earth, the first steps to Mars, and a number of principal investigators in the technology area got to take their stuff down on the Antarctic continent and make it work rather than just telling you how good it was going to be. We have a power system in the Taylor Valley that's still operating based on some renewed cells. We have at the South Pole, there's a greenhouse. You wouldn't think it's a great place, but it's where everybody wants to have dinner and a number of other things. So that was a good effort. Discovery of deep sea hydrothermal vents was a major watershed for biology. And this is one of the things that getting a partnership between NASA and deep sea researchers, earlier it was named the Woods Hole Oceanographic Institution was mentioned, they operate the Alvin. You go to the seafloor with the Alvin and you can find things that nobody would guess, including a phototroph, an obligate phototroph that has to live at the bottom of the ocean, but uses light to make a living. It is, one of my proposers said, or one of my review panel members said, they can't believe that you're groveling for photons at the bottom of the ocean. But in fact, there are organisms that do that, which expands the potential for life in the universe hugely. Because you can go to Europa now and expect to find something down there. You can go to Enceladus, see something in the beautiful Enceladian sky. Anyway, we'll do what we can on that. But it was a very important places. And of course, it focuses on energy-driven aspects of ocean worlds. The NASA and these researchers have a great ongoing program using remotely operated vehicles and other things to go into environments that we've never been in before. So I won't work too much on that. One of the things I was really proud of at the time, but apparently the slide doesn't quite fit, it was the Oreos CubeSat. I wanted to prove that the astrobiology committee and the astrobiology community that they could actually do a really good job with small CubeSats. And NASA Ames had pioneered a CubeSat called GeneSat. We adopted that to work on both genetics of E. coli as well as what the solar incidence was, all in a small 3U CubeSat. And it was a really great thing. And what was nice about it is that we flew it in 2010. And 6 years later, Thomas was the principal chairman on a program for the National Research Council that said, you ought to fly CubeSats. And I agree with him 100%. And you get a good project scientist, that'll work out too. Anyway, we had A-STEP came on. This was a tough time in astrobiology because through a bureaucratic mischance, $31 million a year was lost to the program. And that's tough to make up. But we were able to do that and maintain creative activities in the program. Anyway, I won't work on too much of that, but I did want to highlight some of these titles that I got when I was in Montreal working at the Institute of Air and Space Law. One was One Small Step for a Man, One Giant Leap for my real estate broker. Which tells you the potential for not being alone might actually be more positive than, is anybody out there? Or do we already own it all? And then selling lunar resources for fun, profit, and export, a test that the Outer Space Treaty cannot, it really can't pass. We need to do something else in the international framework. Anyway, I'm still working on ethical, legal, and practical perspectives and hope that things will be done appropriately. There are lots of people that I need to thank. And I'm going to go through a list of 800 people right now, and you're going to, all right, well, I won't do that, but I do need to thank a bunch of people, Chris McKay, Linda Billings, Leonard David, all great colleagues, since Linda was the first person to ever book me to give a talk in front of the National Commission on Space. These are people who really helped me in my career, and I'm pleased as punch if I got most of them. I know I didn't get all of them, but they're great folks. And of course, you end up with the SETI Institute Science Advisory Board and Bill Diamond, and I thank you all for that. I thank my wife, Vicki, and our kids for being patient with me while I was doing all this work. And those colleagues won't likely fit into the Moon Village. And there are a bunch of things that are wrong with this document here. For example, somebody's using a mass driver to put big payloads into orbit around the Earth, but into orbit around the Earth, or maybe just a little sideways into Iowa. You have to be careful about that. Robert Heinlein's Moon is a harsh mistress is where I got that. But we need to be careful about how we go forward. And I certainly hope that everybody will be careful as they go forward in the world. Thank you very much.
Okay. Oh, yeah. Yeah.
Sorry, Dave, there's Buffett.
That was great. That was great. You should stay on stage. Yes. Oh. Oh. Congratulations again. I think that showing so many line items from your career on one slide that it can't fit is the sign of a career well led. So are you proud of yourself?
I'm proud of myself as Tristan's proud of me.
Tristan, are you proud? Oh, all right. Thank you. Congratulations again. Please stay on stage. And also congratulations to all of the other recipients of awards tonight. If I could get all of the honorees and the presenters to join me on stage, that would be awesome. Thank you. And as we reach the end of the evening, like I said before, we are joined tonight by Frank Drake's two daughters, Nadia and Leila. So I'd like to have them come up on stage too. So many people. It's great that we can celebrate so many people tonight. So I have a few introductory notes for Nadia and Leila. I have met Nadia before. I know that she is a space science journalist and that she's now the physics editor. You can come on over. Yeah, you're going to speak. She's now the physics editor at Quanta magazine. And a little personal note, the first time I ever met Nadia was at SciComm camp. And she told me this story about a time she went wading through chest-high waters, infested with critters. And I have been in awe of her ever since. And this is my first time meeting Leila, but I have heard that she's an accomplished ballet dancer. She's performed all over the world, and that now she's taken a leadership position with State Street Ballet. So thank you both for being here, and I'm so excited to hear what you have to say. Yeah.
Thank you. I am so proud to be here to carry on our dad's undeniable legacy of hope and optimism in the fields of SETI science, astrobiology, and ultimately life's most important questions. Congratulations to all of the award recipients tonight. And thank you for your contributions and your research. And most of all, your passion and enthusiasm for this very important work. As we look to the future, and the endlessly poetic possibilities that our universe provides us, I invite us all to continue channeling the whimsical curiosity and never-ending starry-eyed wonder that Frank Drake embodied for the whole time he was here on planet Earth. May we continue to look upward and outward with excitement and opportunity at those twinkling stars and unexplored worlds that await our discovery. May we continue to treasure and care for our home planet with gratitude for the exquisite ecosystems below the ocean's surface and appreciation for the incredible beings that we share the sand, dirt, trees, and sky with. May we treat our work with patience and trust, as if caring for the rarest of orchids and cultivating their future. And may we live our lives with meaningful attention to detail and care for all aspects, as if faceting and polishing the rarest of gems until it sparkles as bright as the night sky. Dad loved and appreciated all of these things, the prismatic world up there, The surprising nooks and crannies on Earth where life finds a way. The intelligence of an orchid and the rough cut stones that reveal shimmering gems when given a chance.
That's right. Dad was very much of this earth, but his love for our planet ended up being a gift that enriched our conceptions of the cosmos. Today, we look at the stars differently because of the questions that he asked and the quests that he launched. The stars are no longer cold, distant points of light, but they are realms where life might exist in infinite possibilities that we can't even imagine. And now finally, we're living in an age where we have the ability to find out whether Earth exists in cosmic solitude or if the galaxy is humming with the whispers of other worlds. And when I think about that question, are we alone? I wonder, why is it important to answer for each of us? Why is it important to you, Leila, or Thomas, to each of our awardees tonight? What is it about that question that matters to you, that's meaningful, that's motivational? We heard a beautiful answer tonight from Kendra earlier, an answer that was based both in grief and in hope. And these are questions that I've been asking myself almost constantly for this entire year since Dad left, because I know that it matters to me. And it's easy to say that it's because the answer is profound either way, but I think it actually cuts deeper than that for each of us. I think it's a lot more personal. And so I think for Dad, the answer to that question, why it mattered, actually changed over the course of his life. When he first started looking, he was curious about whether there were other worlds out there like Earth, whether there were other beings like us, whether maybe we could make a connection. But then as he grew older, I think his motivations changed, at least a little bit. And they included hope, because he loved life here so much. And he loved the connections that he was making with people. He had such an incredible amount of joy in the people that he surrounded himself with and in the planet we all share, in the little things, in the blossoms on the plum tree, the birds at the beach, the tastiness of ice cream. And so I think that as he got older, I suspect the part of what his motivation was that he couldn't help but hope that other worlds could be as lucky as we are. And that is my wish for other worlds as well. And as we, and especially all of you who are being honored tonight, carry on Dad's legacy, Leila and I hope that you can all tap in to Dad's perpetual joyfulness, the childlike curiosity that we've heard about so often tonight, and to celebrate the treasures of home, even as you focus on faraway star fields.
Dad would be so excited about this evening and the future of SETI research and discovery. And we are as well. Here's to continuing this research, honoring our planet and its beauty, and always finding delight in the existence of life itself and all of its complex wonders. Thank you.
Thank you, Leila. Thank you, Nadia, for those wonderful closing remarks and beautiful thoughts to leave us with. Ladies and gentlemen, that concludes our celebration tonight. Those of you who got a C or better on the quiz are invited to stay and have coffee with us. I would like to have another round of applause for all our amazing awardee recipients this evening.
Yeah.
Especially want to thank again Thomas Zurbuchen for helping us celebrate tonight, our chairman of the board, Dan Lankford, for helping us celebrate, Nathalie for the leadership of the science that she provides at the Institute, and for all our award recipients, and of course, our Drake Award honoree for this year, Dr. John Rummel. So thank you again. It was wonderful for you to be here. We hope to see you again next year for the Drake Awards 2024.